11th, and we are going to go live this evening, actually 5 o'clock p.m. Eastern. I wanted to hop in and do a couple things. One, remind you of tonight's session, which is at 5 o'clock Eastern, and two, answer a question that I got from one of out on my YouTube site. Somebody had posted a question on the enclosed circuit breaker, and it was Natalio Ramirez. So Natalio, I'm going to answer your question with another video, but I thought it was good enough because it was a good question because I know I mentioned this product a few times, and I've shown its value a few times in various presentations that I've done. So today, what I want to do is tell you a little bit about the closed circuit breaker and help you understand the value of the product, help you understand a little bit more about it. I'm going to reference the 2020 code of the National Electrical Code. I'm also going to reference my 70E document as well and show you some of the areas in both of these documents that this solution is going to help you meet the National Electrical Code, and it's going to help you increase electrical safety. So, and James Smith, I am live, brother. Thanks for joining in. So today's Tech Thursday, and I got a good question, so I just figured, heck with it, I'm going to answer the question live this morning. All right, and we'll talk about this again tonight, but the enclosed circuit breaker is the topic for this session right now, and I'm live right now, James, on YouTube, LinkedIn, and Facebook. So for everybody who's not involved with my YouTube channel, please don't forget to subscribe. Don't check it out. I've got the links. So associated with this post on the enclosed circuit breaker, I've got 1.5 beard. Yeah, gotcha. And I still have a little bit of hair up there, you know. And I got my power tie on today because this is a power product. This is an awesome solution that I think, if you don't know about it, if you have questions about it, I've got links down below or up above, depending upon the platform you're viewing this on, regarding the enclosed circuit breaker. So this puppy weighs in at 600 volts AC, from 15 amps to 1200 amps, full range of NEMA rated enclosures. What does that mean? I can put it indoors, I can put it outdoors, I can put it in the rain, I can put it in the snow. And the most valuable part of this whole thing is it has the arc reduction maintenance system is available within this. Now, if you recall, I believe it was a couple Tuesdays ago, I'm not sure, over the last couple weeks, I did a session that talked about ways to increase safety. And I think I had, was it 10 ways? I don't know, 7 ways, whatever. I can't remember the number. But number 2 was move the energy. Remember, I said, put the energy in the U-Haul and ship it out. This product that I'm talking about today is going to give you that U-Haul. It's going to give you that ability to move the energy and address the incident and energy downstream. Right, Bill? Mr. Shell, Mr. Smith. All right, so remember, this was the scenario. I had a transformer. Remember, we said that the secondary of a transformer is one of the most dangerous locations in a power distribution system. Where's another dangerous location? If you're working on pieces, you have equipment, you have like industrial control panels or something where you know justified energized work is going to occur. That little red box could be a panel board, switchboard, switchgear, motor control center. It could be an industrial control panel. It could be a mixer in a bakery. It could be a motor, enclosed motor controller that's on a fan of some sort. It could be a industrial control panel in front of a process on a manufacturing floor. And if you think about safe work practices and one of the reasons why you might perform justified energized work is to conduct you're doing troubleshooting, right? So What we said was move the energy, take that main overcurrent protective device, or you could leave it in that enclosure if you want it there, or you could move it out and put it in next to the equipment. What does that do? It does two things. One, you take advantage of the arc reduction technology, the overcurrent device that's in that little separate box, that red box up there. The incident energy in that box is going to be high, but the likelihood of you having to get into that box is slim to none, right? And if you do, then you know you've got the device number one. Now this could be your service entrance equipment as well. And then that device number one is really who? The utility. But in this case, you're controlling the environment. Remember, it's about controlling the environment for the electrical worker. You are putting in place a method for two things. One, for them to establish an electrically safe working condition by putting this in a separate box as close to the equipment as possible. Because remember, availability is critical when it comes to safety solutions. Just think about it from personal protective equipment. If you are on a job site and your PPE is in the truck, the likelihood of you going back to the truck to get on that PPE to do whatever it is that you just found you have to do is probably, I don't know, it's mediocre. But if your personal protective equipment was actually back at the shop about 10 miles away or a 15-minute drive away, the likelihood of you driving back to get it and come back again to do your work and put your personal protective equipment on is probably slim to none. So availability for safety solutions is critical, and this helps you get it done. Robbie Vargas, good morning, sir. Good morning to everybody out there in Tube land, in LinkedIn land, and in Facebook land. Robbie Vargas in the house. All right, so the enclosed circuit breaker is an important product, and I mention it a lot of times in many videos of mine. I mention the safety disconnect switch, the fusible disconnect switch, in a lot of different presentations of mine, but a lot of us know exactly what a fusible disconnect switch is, but you may not know what an enclosed circuit breaker is, and that's why Natalia Ramirez, that's why I'm putting this together to help answer your question and probably a lot of questions in everybody else's head. So the information that I have here was taken out of the materials that I have. I put all the links to this solution in this post. So you've got to go anywhere other than this post to find the technical brochure data that'll get you all of the NEMA types, all of the wiring schematics, images like this of the internals. Over there on the right, you'll see that's the little blue light. What's the blue light? The arc reduction maintenance switch. And it has the ability to lock and tag out. So you can basically turn on the arc reduction maintenance switch, lock and tag it out, and provide what you've done is you've reduced the severity. Because be mindful, what is incident energy all about? Current and time. Clearing of the arcing current is what you're trying to do. And the further down you get into a power distribution system, the lower the fault current is, which will mean the lower the arcing current is. And at the lower voltages, the arcing current is even lower than at the higher voltages. So you could have a 600 amp at 600 amps at 480. We'll put that info link not in YouTube. Wow. All right. I'll have to take a look at my YouTube site. Thank you, James. It should be in the description. Really should be in the description. I'll have to take a look at my site here and see what the heck is going on. I think I'm live. There I am. Let me just take a look at the description. Yeah, it should be. It's down below. It's take a look in YouTube. There's a few links to, oh, I know what it is. James, I know what it is. The problem is you probably can't click on those. If in those descriptions, I don't know if they make them hyperlinks. You might have to copy the text and post it in the, you might have to copy those links. So anyway, what I'll try to do is maybe towards the end here, I will post the links in the chat. So those links will get you to this technical information. Let's just go back to this. So it'll get you into that information. And one of the important parts, near and dear to my heart, is establishing the catalog number. right? So you've got to go to the catalog number systems. I like the way the product line puts these together. And I know when I was a product manager for communication hardware and software, AFCIs, GFCIs, and the other products that I've worked with, these breakouts, there's a lot of thought that goes into the catalog number system, because I mean, it's just a string of numbers recognizable by a computer, and probably one of our seasoned or many of our seasoned sales and application engineers out in the field, we know this key, but not everybody knows the key to those catalog numbers. So this tells you the AR tells you that's an enclosed circuit breaker. The 3 in this case tells you it's a 400 amp. The S tells you that it is a standard. You can have a high, standard or high. That is the short circuit current rating. And remember, since this is an enclosed overcurrent protective device, the short circuit current rating is going to be the interrupting rating, but not in all cases is that true. So we've gone through the steps to make sure that everything, all the different components, any of the power distribution blocks, anything that we use in there has a 65K, 35, or a 50K short circuit current rating. The A tells you if it's ALSI, meaning arc flash reduction, long time, short time, and instantaneous. The B tells you it's an ALSIG, arc flash reduction, long time pickup, short time delay, instantaneous pickup. And what do you think the G is? Give you a second to put it in the chat. What do you think the G is? It's not G. Your hair smells terrific. Ground fault. All right. It's ground fault. And then the next one gives you, you have a 1 through 4. That tells you the voltage, the control power transformer voltage ratings. And then you have neutral, with a neutral, or no neutral. I'll tell you the type of system that you're going into. You have the terminals that you have. So all of the different types of terminations are in there. The NEMA enclosure, look at the NEMA enclosures. 1, 3R, 12, 4, painted, 4X stainless, 1, 100% rated, 3R, 100% rated, 12, 100% rated. If you don't know what 100% rated is, I've got a program on that too. I'll try to put the link. I didn't put the link down below, but I'll try to put a little tag up above on this one. NEMA 4 painted, 100% rated, NEMA 4X stainless. Ooh, ooh, ooh. All right, and then you have all the different options. You have auxiliary contacts. You've got shunt capabilities, painted white. And I'll tell you what, this is out of our Flex Center, which I call the custom shop. They'll paint it pink if that's what you want, right? They are a build to order. They will make whatever it is you want, whatever crazy types of situations you get yourself into. Our Flex Center, I lovingly call it the custom shop, will do whatever you need. And we have them across right here in the United States, across the country. We can build to order, and they would love to take your order. I've got a link down below for more information. You can just click on that, put your information in, and you can ask for additional information. But what else you need? You got the decision right here. You're going to get it. You know where you're going to get it, and you're just going to click on it, and you're going to order about 300,000 of them. And when you do, make sure you reference my name. I'm not going to get any credit for it. I'm not going to get any kickback for it, but just mention my name. That way the sales guys know, hey, this came from Tom. All right, we have the enclosure size. So the reason I put this in here from a size perspective, put these products closer, as close as you can to the equipment you're trying to provide the protection for, right? If it's a panel board, try to put it next to the panel board. Why? Because we want to facilitate the electrically safe working condition. We want them to pull that handle to the off position. We want them to go through 70E. Let's talk a little bit about all the cool stuff. So here's some of the references that this product, outside of 24087, and we have 24067 solutions for these as well. Right now, since the question came in on the enclosed circuit breaker, that's what I'm focusing on. But we have a fusible disconnect switch with an arc reduction maintenance switch on it. And it's amazing as well. It helps you get those lower arcing currents. Remember, further down the power distribution systems you are, the lower the voltages you are, the lower those arcing currents are, the longer the clearing times, the higher the incident energy. 24087 and 24067, 1200 amps and above. 2023 is moving it to 1000 amps and above. Article 110. Now I'm in 70E. I'm in the 2021 version of 70E. 110.1, what's your number one priority and why you need to put this as close as you can to the equipment where if anybody even thinks that what they're doing is justified energized work, they may want to question that. If it's really easy to establish the electrically safe working condition. 110.1 tells us the priority for safe work practices is hazard elimination shall be the first priority in the implementation of safety-related work practices. That says a lot right there about this solution. The electrically safe working condition. Energized electrical conductors and circuit parts operating at voltages equal to or greater than 50 volts. 50 volts is your magic number. You want to help the customer establish or help your facility establish an electrically safe work condition. Infeasibility tells us, one of the options in there is when you're performing troubleshooting. And that's why in our facilities, we'll put the enclosed circuit breaker in front of equipment we know where justified energized work could occur. We promote establishing the electrically safe work condition. Pull that handle, lock and tag it out, go through the procedures in 70E to establish an electrically safe work condition. But when that's impossible and you've gone through your hot work programs and all that other good stuff, you've asked all those questions, why can't we shut this down? And you can't. Put this puppy in arc reduction mode and you will reduce the severity. So that hierarchy of risk controls, what in 110.5, 110.5 I3, I is elements of a risk assessment procedure. You have to understand the hierarchy of risk control methods. This is right up in the sweet spot of risk control. Why? Because you are reducing the hazards. You are facilitating establishing the electrically safe work condition. There's a lot of things that work to elimination, substitution, engineering controls, awareness, and administrative controls and personal protective equipment. We hit all 5 of these, 6 of these in different ways. So this solution is absolutely critical. I've got a meeting coming up in about 4 minutes, so I got to get through this. Article 130, I'm just going to give you some references. 130.2, energized electrical work permit. When required, all that great stuff. So work involving electrical hazards, Article 130. 130.2 B, elements of a work permit says results of the arc flash risk assessment. Just think if this piece of equipment is ahead of you, when you do your arc flash risk assessment, you're going to show that the severity is very low. Light wear, maybe just gloves, goggles, and whatnot. You're not going to be in a 40 cal outfit or an 8 cal outfit. You're going to be in daily wear, hopefully with some light personal protective equipment, but follow the procedures here. Another area, in 205, general maintenance requirements. The single line diagram. Why do we need to know a single line diagram when we're doing maintenance and things like that? We need to figure out how to establish an electrically safe work condition. What better way than put the only disconnect right next to the equipment? You don't need to go and figure out where in the power distribution system is your disconnect to establish an electrically safe work condition. I got 3 minutes. Rotating equipment, overcurrent protected devices in 205.4. We got those puppies in there. All right, so I mentioned a few key sections in here. And remember about the short circuit current ratings, already mentioned that. And finally, don't forget www.youtube.com/c/Thomas Dimitrovich. If you're not already out there, if we're not already subscribed, if you're not following, today is Tech Thursday. We're going to be doing ground fault short circuit calculations. We're going to be talking symmetric. Look at the topics down here. I have complex variables. I've got fault current calculation lab. That's where we established a one-line diagram. We went through and we're calculating short circuit currents. We've done it by hand. We're verifying our answers in SKM. I'm going to do ground fault currents tonight. So bring your positive, negative, and zero sequence caps tonight because we're going to be talking about symmetrical components. We're going to be flexing our complex variables. We're going to be leveraging and putting our calculators to work. Bring your favorite calculator. your best pen. Remember, you can pause, you can come back and visit, because this material is up there and it will be for a long time, and we're going to continue to grow. We are international. So please check out the site. Don't forget, breaker, the enclosed circuit breaker, great solution. And I think one that should be on your approved list in your specifications. If you need help with specifications, let me know. I'll get you one of our field application engineers who can work with you one-on-one to help you figure out what is the right product for your application. It is 8:29. I need to start this other computer going and get on a phone call with Joan, and we're going over some presentation materials and stuff like that we're giving. So any case, have a great day today. Have a safe day today. And remember, stay safe. Thank you for what you do for the electrical industry. Thanks for what you do for electrical safety. And remember, stay healthy. All right? And keep all of those all your loved ones and whatnot that you know are sick. There's a special person in my life who's sick, and we're thinking about you. Take care. God bless.